Hi there. Here is how I would look at the Power Models study guide. So first of all, I have the data already in the calculator. So we are looking at, can you predict a mammal's lifespan from its body weight? So I have the weight data in list 1. I have the lifespan data. That one is in list 2. So I would assume that you already know how to make just a simple scatter plot of the original data. So I've put it into list 1 and list 2 with that plot on then. We're going to press zoom 9. It should be pretty clear that a linear model doesn't make a lot of sense here. Let's go to the calculator. So here's my scatter plot. If I go to second y equals, my scatter plot is on. I'm using list 1 and list 2. So we'll press zoom 9. It's pretty clear that this is not a linear trend. So this is pretty clear that we've got a curved trend here, and a linear model doesn't make sense. So the first type of nonlinear model that we studied was an exponential model. So the study guide asks you to first of all see if an exponential model makes sense or not. So let's take a look at that. So in particular, recall that x and y, data of the form x and y, so what we have in lists 1 and 2 can be modeled exponentially using this style model. So we have a constant times a base to the power x, where x is our explanatory variable. This model is appropriate if, when we transform the data, if we look at x and the natural log of y, so the plain explanatory variable, but the log or the natural log of the response variable. If this scatter plot is linear, then an exponential model makes sense. So the first thing you have to make sure you've done is execute these commands. You could use common logs if you would rather logs base 10. I'm just using natural logs. So you have to make sure that you have converted both of these into lists 3 and 4. We're going to take the natural log of the explanatory variable and put that in list 3. The natural log of the response variable, those are the y's, and put them into list 4. So actually this is the one we need right now in order to test to see if the exponential model makes sense or not. Because remember, it's list 2 where the y values are. It's list 1 where the x values are. It's these data that we will use later on. So let's make sure we've done that transformation. So on the home screen, we'll take the natural log of the x values. Those are in list 1, the values of the explanatory variable. We're going to store that into list 3. We will use those later. So second, we need to take the natural log of the response variables. Those are in list 2. Those are the y values. We're going to store that into list 4. Very good. So again, what we need to look at, we need to change our statistical plot. So in plot 1, our stat plot, right here, list 1 are the plain x's. That's what we want to look at, but we want to compare them to the natural log of the y values. So instead of list 2, I want to use the natural log of the y values. Those we put into list 4. Very good. If this plot is straight, if this is straight, this is suggesting that an exponential model would be a good plan. So if I zoom 9 this, it should be pretty clear that that is not a straight line. And that's really all that you're being asked to observe in question number 1. Take a look. So we did this. We set up a scatter plot using list 1, or our plain explanatory variable, as the x list, and list 4, that was the natural log of the response variable, as the y list. We hit zoom 9, and then we're supposed to explain then why this scatter plot tells us that an exponential model is not appropriate. Well, simply put, it's not appropriate because the pattern that we saw is not a straight line pattern. So that means that we need to consider another type of model that is a power model. So here's an example of what we mean by a power model. It has this form right here. We still have y equals a constant, but this time notice now the explanatory variable is the base and the exponent is b. The exponent is the constant. And this is what you're supposed to observe in question number 2. In question number 2, it says in the power model, the value of the explanatory variable, or x, it's the base. The constant b is the exponent. How is the exponential model different? Well, essentially the roles of x and b have been reversed, because in the exponential model, notice the positions of x and b are backwards. In the exponential model, b is the base, it's a constant, and the explanatory variable x is the exponent. That's why this one is called exponential. This model is called a power model because you are taking your explanatory variable x and you are applying a constant power to it. So now, just like we did in class with the exponential model, look at what happens if you take the power model and take the natural log of both sides. So we can take the natural log of y. On the right side, we can take the natural log of the product of a and x to the power b. So again, because these are multiplied together, I can split the right side into two pieces that are added together, the natural log of a plus the natural log of x to the power b. And I can take this b, I can take the power here on the argument of this natural logarithm. I can put it in front of the natural logarithm. But then understand what we have here, we have turned this into a linear model. So remember, a linear model looks like this. We have an output, and that should equal a constant plus a slope times an input. That's what a linear model is. Most simply put, you have an output, and that output should equal a constant plus a slope times an input. Okay, well, notice we have an input. Here it is. The input is the explanatory variable, the natural log of x. There is our input. So I'm going to check that off. So the response variable is now it's not just y by itself, it's the natural log of y. So that entire expression, the natural log of the y value, that represents our output. So now this model also has a very specific slope. Here is our input, the natural log of x, and it is multiplied by a constant. That value is b, the b all by itself. So we do have a slope. That's just the plain b. And this also has an intercept. The intercept is a constant. It is the natural log of a. There it is. So this really is a linear form. So when I look at this form, here is the input, the natural log of x. That's our explanatory variable. Here is the output, the natural log of y. And to get that output, we really are taking a slope of b times the input, the explanatory variable, and we are adding to it a constant value. That is the natural log of a. So here's the test then that we need to run to see if a power model makes sense. So notice what this means. X and y, so the original explanatory and response values, x and y can be represented with a power model if I transform the data. So notice, if I look at both the natural log of the explanatory and the response variable, if I'm natural logging them both, if this is a straight line relationship like we saw on the front, if this converts x and y into a straight line relationship, so if the natural log of y compared to the natural log of x, if this is linear, then that is suggesting that this power model right here is a good fit. So that's the next thing to do here. So in part 4, that's what you're going to do. You're going to set up a scatter plot using list 3. That's the natural log of x. That's the x list. List 4, the natural log of y. That's going to be the y list. We're going to hit zoom 9, and we're going to see this time if we get a straight line relationship. So to the calculator. To our statistical plot, second y equals, we're going to go in. So I want to compare the natural log of the explanatory variable of the x's. That's in list 3. And I want to compare that to the natural log of the y values. That's already list 4. So that looks good. Let's zoom 9 it. Oops, hit the wrong button there. Let's zoom 9 this. So notice, although there is some variability here, let me go over to the bigger screen on the right. Although there is some variability, I could fit a straight line relationship through this scatter plot. So notice this is comparing the natural log of x to the natural log of y. So certainly compared to the first plot that we saw, this is certainly linear, or much more so. So this suggests, and that's what question number 4 is about, this is suggesting then, because that scatter plot looking at the natural log of x compared to the natural log of y, so we're looking at this relationship right here, because that is a straight line relationship, a power model is appropriate. So essentially what we have left to do, questions 5 through 10 on the study guide, is to fit that power model, to use that power model to do some predicting, to estimate that model, to describe its strength. So that's the next video.